Okay, in this tutorial we're going to be looking at the effect of A on a tangent graph, and we're going to eventually draw here on our page y equals 5 tan x as our example. But the best way to do this is a similar method that we used last time using our calculator. So I'm going to have our calculator there again, and I'm going to zoom in a little bit so that we can see the screen a little better. It's as big as the zoom goes on this thing. Okay, so here we have our calculator. So our window that we're going to use, so let's turn it on. And let's clear this. This is from our last tutorial. And let's go in here and clear this stuff up. That was from when we did cos. And let's go to the window here. And I'm going to use the same window. I want the same period, one period of negative period to negative 2 pi radians to positive 2 pi radians. And I want the scale to be pi over 2 radians, or 90 degrees every little or every notch. And I'm going to have the maximum still be at negative 5 and positive 5 for the y values, and the y scaling to be 1. Okay, so now what we're going to do is we're going to put in each of the graphs. So let's first start with our basic graph. So hit y equals and go tan bracket x, close the bracket. And let's graph that to remind ourselves what it looks like. So there is the regular looking tan graph. So now let's put in our graph where we increase the size of the a value in front of the tan graph to a 5. So let's put our y equals button here. Let's go down to the second one and put in 5 tan bracket x, close the bracket. So now hit the graph button to see what the change is. So first of all, we'll have the tan x graph coming in. And then the 5 tan x graph will come in right beside it. Whoa, look at that. It's almost a straight line in there. Okay, not as curved at all. Okay, so it still has the same 0 points and the same asymptotes. That hasn't changed at all. Same 0 points and same asymptotes, but the steepness, it became more like a straighter line. Okay, much straighter. Okay, so let's clear that off. Or let's not clear that off. Let's go to y equals. Let's pretend that it was a negative in front. Okay, I didn't show you a negative in the last tutorial. What happens when we have a negative in a tutorial, because I forgot. But let's say we want to put negative 5 tan here. Negative 5 tangent x. Okay, now I took the other one off so that the screen wouldn't get as loaded. And let's see what happens here. Hit the graph. There's the regular tan x one. And here's the negative one. Okay. Notice that the negative one have switched it. Instead of going the same direction, it's going the opposite direction now. And it's still less steep. Okay, so now we've discovered that if we have a coefficient greater than 5, it makes the tan graph less steep. And we've also discovered if the coefficient is negative, it switches the curvature to the mirror image, okay, of what a tan graph would be. Now we have to just, what would happen if it's less than 1? So let's do that. Let's go back to the y equals and clear that second one now. So let's put in a half or a third or something like that. Let's put in a third. Let's go bracket 1 divided by 3, close the bracket, tan, bracket, x variable, close the bracket. And then graph that. Okay, the tan x graph is there. Okay, it's not going to be reversed because I didn't put a negative in front. It's going to be the same. But look at that. It's approaching much quicker to the axes. So if it's less than 1, it curves out quite a bit quicker. Okay? So if we were to draw then, if we take this away and I unzoom, and I were to draw this now, I would have the same shape of the tan graph, zeros in the same spots. Because it's not a negative, it doesn't change direction. So put the 0 there, 0 there, a 0 there, a 0 here, and a 0 here. And instead of approaching at the regular tan, so if this was here, let's say this is 1 here, and this is 2, 3, 4, etc. 1, -2, -3, and -4. So halfway through would be about a 1 there on a regular time graph. So it's going to be much more steeper. So it's going to be quite a bit steeper graph. Almost kind of like a straight line there. Hard to see the difference really sometimes. But a much straighter graph. Now remember again, if going to this side, it's going to be a much straighter graph there. Much straighter graph up there. So straighten your graph out because of the large coefficient of A. Okay, and I didn't show you in the last tutorial, so I'm going to quickly show you the negative value here, as I have lots of time with the sine or cosine graph. So let's just go back to our calculator. And let's clear this, and let's put in our window. Let's keep it the same here, okay? Still has -5 and 5. And instead, when I go to y here, let's clear these. Let's put a sine graph down, sine x theta. And let's go negative sine x theta. Or -1 times sine x theta, so it won't change the amplitude. Well, let's put -2 so that we can see the difference here. Let's go -2, so -2 sine x theta. There we are, and let's graph those two. So there's the sine x theta, and the negative. So where it was going down, now it's going up, and where it was going up, it's now going down. And it's also going up to 2 and -2. So what the negative does is it switches the maximums and minimums around, even on the sine graph as well. Just wanted to quickly remind you of that. So we can summarize it in saying that A changes the amplitude of the function for sine and cosine. If it's negative, it changes the minimum to a maximum and the maximum to the minimum. It does not change the 0 points. And for a tan graph, if you have a large A, it will straighten the tan graph out. If you have an A that's smaller than 1, it'll curve it more towards the asymptotes. Here's a little summary. And I think they do have a summary in the book at the end of the chapter, but we're still not done because we still have to look at the effects of the B coefficient, which we'll be doing in our next few tutorials.